The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to our new live webcast. Who are you? Authentication by certificates. Join us each month for new powerful messages, technical tips, and success stories that will leave you inspired and ready to get your protection, licensing, and security techniques another step closer to perfection. At WIBU-SYSTEMS, we empower software publishers and intelligent device manufacturers with cutting-edge technologies, new business models, and tailor-made consulting training. Let us help you upgrade, optimize, and automate your entire license lifecycle management so you can focus on monetizing your business at a higher level. My name is Daniela Previtali, Global Marketing Director of WIBU-SYSTEMS, and I'm delighted to have you here with us today. We are joined by Stefan Bamberg, Senior Key Account and Partner Manager, and Philipp Lütke, R&D Software and Deputy Information Security Officer, both from the headquarters of WIBU-SYSTEMS. Digital certificates have proved their worth as a strong means of authentication for decades. With IIoT taking center stage in industrial automation, machines need to be identified securely as well to stop illicit users of systems from sneaking in and potentially wreaking havoc in networks. X509 certificates, coupled with communication protocols like OPC UA and hardware-based safe storage solutions like CmDongles, are ideal choices to meet the challenges of today. Some housekeeping we need to take care of before we start. For everyone who's joining us today, I want to remind you that we will be reserving some time at the end of the session for Q&A, and I'd like to invite you to submit any question you have in the live chat box. This session is being recorded, and a link to the replay will be posted directly to you in the next couple of days. And don't forget, stay with us throughout the live session for your chance to win an Amazon coupon worth €50. At the end of the webinar, a new tab in your browser with 3 simple quiz questions will show up. You can submit one choice for each multiple answer question. We will draw the winner from among those who reply correctly and notify them at the time of the replay announcement. Please also note that the winner is excluded from all subsequent prize draws of 2020. Without further ado, I'll pass things over to Stefan. The floor is yours.
Yeah, thank you very much. My name is Stefan Bamberg, and I want to welcome you to the last webinar before our summer break with the title, Who Are You? Authentication by Certificates. If we all talk about certificates, most of us are very scared about that. That is a topic that seems to be very difficult. And Philip and me today want to show you that it is not as bad as it looks like. So we want to have a short introduction to the certificates to bring you on the latest status on that. We want to show you some application scenarios where certificates are very good for the use cases. And of course, we want to give you an inside view to our CodeMeter Certificate Vault that helps you to use certificates and to handle certificates. So the question, who are you, is more or less the question, who am I? So sometimes I have to prove my identity. I know who I am, but does you know who I am? So in certain situations, I have to identify myself. For example, in a police check, opening a bank account here in Germany, it is necessary to prove the identity with an ID card. If I want to register a new vehicle, I need my identity card to show that I'm the one who wants to get registered for the car. The kids, or I don't want to say the kids, the teens are very interested to have such an ID card, because the purchase of alcohol in Germany is only possible if you are older than 16. So you have to prove that in the supermarket if you want to buy something like that. And everyone who ever fly with an aeroplane sees at a check-in that he has to present his ID card to prove that he's the one who has bought the ticket. So in many more cases, you are forced to identify yourself against someone. And that's exactly the reason what we are talking about. And how does that work? So we have three parties involved in that. So the lady on the left side, who has to prove the identity, a police officer on the right side who wants to check her identity, and of course an authority that that issues the identity card that is necessary for her to prove her identity. So in this case, it's an ID card, it's a travel ID card, whatever you need for that. And this ID card is issued by this authority. They prove, they check, they double check if you are the right person. And if you have such an ID card and you get into a police control, for example, then you have to show your identity card to prove your identity. And in these cases, the police officer checks the ID document and checks it against the background system, for example, that shows some entries, if I'm an evil guy or not. And if that check is done, the result of the check is transferred to the police officer, and then he can decide to approve or reject what I want to do, or he wants to prove my identity, and then the identity is checked by the police officer, and that's fine at the end.
Yeah, hello from my side too. So we need, in a digital world, we need a proof of identity too, because digital communication and networks are getting more and more important, and we have to secure them. And especially we have to know who is communicating in our networks. And that's why we need authentication. How can we achieve authentication in a digital network? We don't have only persons to authenticate themselves. We even have machines who must be authenticated to other machines in an automatic way. So, and that's the question, how can we do this? And the answer is, as you may expect it, certificates, especially for more specific X509 version 3 certificates. In the following, we will explain you how certificates works, what they are good for, and how you can use them. To understand certificates, you need first a basic understanding of the cryptographic mechanism behind.
Yes, and that's the reason why we dive a little bit deeper now into cryptography algorithms. So there are two different types of cryptography. So the symmetric cryptography, where you have just one key to encrypt and to decrypt data. That's an easy thing, but it's at the same time a downside, because you have to share this key that you use for the encryption also with the one who has to decrypt or wants to decrypt the information. The most used cryptographic algorithm is the AES, the Advanced Encryption Standard algorithm. It's a symmetrical procedure, and it is used for a large amount of data because it's very, very fast. And so you can encrypt and decrypt data in a very short time, even if it is a large amount of data. The opposite of that is the asymmetric cryptography. So we have a public key cryptography. Maybe you know that from email encryption that you use. You have a public key, you have a private key. So this is the so-called key pair. And it's impossible, that's the most important thing, it's impossible to derive the private key from the public key. So you have to keep the private key secret. And you can share the public key with all of the ones you want to have an encrypted communication with. And that's a very good thing. It's, of course, much more slower because you have to calculate more in case of an asymmetric algorithm. But it's the most secure one that you can, more or less, the most secure one you can get. So the most common one is the RSA, named after the mathematics guys, Ribes, Chimere, and Edelman, and it's very popular. And if we, for example, check for the usage of such an asymmetric encryption, then we take the email encryption as a first example. So Alice wants to send Bob an encrypted email. And how does it work? So the first step is that Bob transfers the public key, his public key, to Alice. So there is no secret inside. you can share it with everyone you want to have an encrypted communication with. And if Alice sends now an email to Bob, then she uses the public key. She encrypts it with their email program and sends it to Bob. And Bob is able to decrypt the email now because he has the private key that allows him to decrypt the message. So that is the basic algorithm and the basic process how the encryption works. Encryption and decryption works with a public key algorithm. The challenge is, of course, that Bob has to get the keys and that the keys has to distribute to the different roles and people here. And we will show later on how that can be achieved just by using special algorithms and infrastructures. And of course, the solution to all of these things is, of course, a certificate, a digital certificate. And how does that work, Philip?
Yeah, thanks, Stefan. Certificates can solve the problem of key distribution because they link identities with cryptographic keys. Why can they do this? Because they contains information about an entity. So an entity is an actor in a process. So it could be a person or it could be a machine or everything else. Yeah. But it does also contain information about the public key. Yeah? And there's the link, identity with the cryptographic keys. The structure and the contents of a certificate is standardized by RFC 5280. RFC is short for Request for Comment. That's the standard name for specifications from Internet technologies published by the Internet Engineering Task Force. Yeah, the information and the content of a certificate is signed, and that's why you can prove the authenticity and the integrity of a certificate by validating this signature. Yeah, here's some examples what is actually included in a certificate. Version 3. So we have a version number and the serial number to identify the certificate, the name of the issuer, who signed the certificate, the name of the subject to whom belongs the certificate, so the information about the entity I just mentioned, the period of validity, so from when until when it's valid, and of course the information about the public key. And then we have some extensions. Yeah, they were added by version 3. So with this extension, you can specify more information about the key, about the usage of the keys. For example, you can only use a certificate for email, signing, or encryption. And yeah, there's the possibility to add URLs or IP addresses and much more stuff. Yeah, as already mentioned, the information are signed with a digital signature. And of course, you need to know which algorithms were used to create the signature and the keys. So here we have an example how a certificate looks like. So you see all the fields I just mentioned. You have the version at the top, the serial number, and then the algorithm which was used to generate the signature. We have the issuer with some information where it comes from and who it are, common name, CN, and the email address we have here. Then afterwards we see the valid date, so not before and not after, as mentioned. And then comes information about the public key. Yeah, and then you see at the bottom we have this extension I just mentioned. So like key usage, this one is for digital signatures and data encryption and cipherment. Yeah. Okay, so far.
Yeah, so let's compare the digital world with the analog world. So please remember the picture before where the lady has to prove her identity to the police officer. So if we transfer that in the digital world, then there is an authority, there's a question mark, we see in a few seconds what it really is, that issue a certificate to the lady. It's not an ID document, it's now a certificate. And the lady is now able to prove her identity to a machine or to a device or to a server, for example, to make sure that she is really allowed to get access to these devices. It's possible, for example, to use a dongle for that, and the certificate is checked every time. So it's like the police officer that is checking the result of the ID document. And with this certificate, the authentication is done against the device, and so she gets access to the device. Or if that certificate does not fit or is not longer valid, she don't get access to that system. So the question mark is now the so-called public key infrastructure, PKI. And what is a PKI now? The most important thing is that it's actually an infrastructure, not just a software application. That's important to say because it's much more than just a software to manage all the things. It consists of a certificate authority, so-called CAs, and the underlying processes. And we will dive much more deeper in the processes later on to see what processes that are. It is hierarchically structured as follows. So we have the root CA, the basic one, which you have to trust, and several derived subordinate CAs that are derived from that root CA. And every certification authority holds a key pair and a certificate to be able to identify themselves. And the most important task of a PKI is, of course, issue and manage certificates. And let's have a closer look to that processes.
Yeah, thank you, Stefan, for your explanation. Here we see an example how a PKI can be structured. So we have the root CA at the top of its certificate and the sub CAs below. So you see each sub CA has a certificate signed by the root CA, but the root CA has a so-called self-signed certificate. It was signed by the private key of the root CA itself. Because we don't have any CA above the root CA. We have to put all our trust in the root CA and that they do their job right and they issue certificates only to valid and proven persons or identities. Yeah, and then the advantage of this structure is to have different sub CAs is you can specify which sub CA is allowed to issue which certificate. So for example, sub CA A can only issue certificates for email signing and encryption, and sub CA C is only allowed to issue certificates for server TLS usage. And another big advantage is that if one key gets compromised, example key from sub CA B gets compromised, then only the certificates from sub CA C or issued by sub CA B must be revoked, but not the certificates issued by sub CA A. Okay, so far. Here we have the first process which is needed because the question is still open, how does Alice get their certificate from the CA? So Alice has a private key. With this private key, she can now sign a certificate signing request, CSR. And the signing request contains all information which is also contained in the certificate later on. So her name, and even the information about the public key. So this will the CSR gets transmitted to the root CR, and these will check the identity of Alice. Here we have our ID card process back. So the CI has to prove the identity of Alice if it matches to the identity in the request. If this is valid, then the CR will sign the certificate for Alice and send back to Alice. Now Alice got the certificate and can use it. If you remember the example from the beginning where Bob wanted to send an encrypted email to Alice, and the question, how get the key distributed to Alice? Here's the solution. Alice now wants to send a signed email to Bob, but this time she also attaches the certificate to the email, and the certificate contains the public key. That's the way how the key gets distributed to Bob. Bob now has to validate the certificate of Alice to be sure that it's really Alice who sent her email signed. And therefore, Bob needs to trust the same root CA as Alice, where Alice got the certificate from. And yeah, if he trusts this root CA, he can validate the certificate from the root CA. So validating a certificate means checking if it's still valid, so the time periods, if they are still valid, and if the signature of the certificate is valid. After that, he can verify the same steps with Alice certificate. So is it in the valid time period, and is the signature valid? Yeah. And as you remember, we can have chains of CRs, like you have seen in an example before. We have the root CR and two sub CRs, and then you have to validate each certificate in the chain to get result.
So now we, on a high level, know how certificates work and the processes work to distribute, to enroll them. But how to use certificates now? Where to use the certificates now? So we have some application scenarios where it makes sense to use certificates. We touched the topic email encryption before, and signatures, of course. So you are able to encrypt it, or you can even say this email really comes from me. That is the signature of an email. But also document signature is a very important topic, especially nowadays in the corona times. If some people have to sign a contract, for example, and they are working in the home office, then it's very difficult to send it from one person to another person. So it makes sense to use certificates instead, digital certificates, to sign a contract so that it is okay for the in front of the law. So document signature that is supported by Adobe Acrobat, by OpenOffice, gets more and more important. Email encryption is supported by nearly all major email applications on the market. But also securing communication on the web is a hip topic, because we only want to connect to websites that are available with HTTPS as a secure protocol, so that the communication is encrypted between my machine and the server machine. So it's uses for TLS, for example. And it's the same thing in Corona times when I want to work in my home office. Then my company issued me a certificate so that I can be authenticated by our internal server machines when I use the virtual private network. So I have to enter the VPN, I have to show my ID card in form of a certificate, and then I am allowed to have access to all the machines to use servers, directories, or something like that. Of course, in the field of Industry 4.0 and IoT and IIoT, the authentication of machines and applications are very important as well. So if I want to enter a machine, for example, with a Windows Smart Card login or SSH, then I have to show my certificate or use my certificate as well. And even if machines are communicating with each other, which is the base for Industry 4.0, then we need a secure communication and authentication in the industrial environment. And we will have a short example later on when talking about OPC UA, which is a standard interface between devices and devices that interchange data, and even with devices of different brands, but they are all talking the same language using OPC UA. But there you have, of course, to secure the communication between these systems.
Okay, now we have an understanding of the X509 system and all what is happening there, what I can do with certificates. But there are still some challenges you have to solve if you want to run your PKI. And one is to the rollout or enrollment of certificates. Yeah. So there are three questions to answer. How do I do the authorization check? Yeah, to check if a person is really permitted to get a certificate from my PKI. There are some different ways to do this. but they have to fit your needs, your environmental needs. And then, of course, the technical rollout. How do I distribute the certificates? Do I provide a download link, or do I send them out per email? And least but not, but the important one is to keep the keys safe of the certificate. If you cannot keep your keys safe, then the certificate is worth nothing, because everyone could fake your communication or decrypt your communication with the stolen or compromised key. Yeah, these questions you have to answer if you want to do it right. And there are several ways to do. And the other point is you have to solve is the revocation or withdrawal of certificates. Again, here we have the point of authorization checking. So again, I'm not allowed to revoke Stefan's VPN certificate. That would be bad. And you have to make a mechanism where to publish your revocation. So there are two standard mechanisms where you can publish revocation of certificates. It's a certificate revocation list, CRL, and an online service which you can send a request with a serial number of a certificate, and he will answer you with a yes or no, it's revoked or it's not revoked. These are the two standard mechanisms, but they both have disadvantages, and you have to figure out which is the one which fits you best. And there's the question of when do you perform the check if a certificate is revoked or not. Yeah, so if I check now if Stefan's certificate is revoked, but a minute later the certificate revocation list gets updated, my check says, okay, it's valid, but a minute later, oh no, it was revoked. So that's questions to handle if you want to set up a PKI.
Yeah, and now when we know the challenges, we want to show you a little bit how CodeMeter Certificate Vault will assist you, will support you in handling these challenges.
CodeMeter Certificate Vault helps you to simplify these processes just discussed. It helps you with the enrollment of certificates, because you can integrate in your already established process of license distribution, the process of key and certificate distribution over the CodeMeter License Center. And you also can connect your PKI or CA directly to the CodeMeter License Center, so that signing requests for certificates are made to the CodeMeter License Center, and the CodeMeter License Center will do the authorization check for the PKI and relays or rewards the signing request to the PKI. And the big advantage, of course, is the hardware anchor, the CmDongle, which is a secure element where you can keep your keys safe and protected from any attacker. Okay, here we have now an example how CodeMeter Certificate Vault can be used to secure communication in an industrial environment. So Stefan already mentioned OPC UA. And here we have an example of two machines who wants to communicate via OPC UA in a secure way. So both machines have the CodeMeter Certificate Vault integrated into their OPC UA application. So one side has the OPC UA server and one the client. And both have their keys and certificates stored in the CmDongle. So now the client, machine B, wants to establish a connection to machine A, to the server, and therefore it reads the certificate from the CmDongle via the CodeMeter Certificate Vault and sends it to machine A, to the OPC UA server. The server can now validate the certificate and will answer with his own certificate, which is again read from the CmDongle. And then they can start to establish a connection with the keys in the CmDongle. So they will use them for encrypting and signing the communication.
Yeah, Philip, you mentioned the CmDongles, which is the best technical way to protect the keys and the certificates. But why is that the case? So let's have a closer look to such a dongle. So in the background, you see the dongle with a small smart card chip on it, and that's a security smart card chip. It's the SLE97 of Infineon. Which has also a lot of certificates, not the digital ones, but the ones in the real world that that prove that the technology is perfectly secured. And we have several form factors available for these dongles. A lot of them are created for the industrial field. So we have SD cards, industrial CFast cards. We have micro SD cards, or on the left side, even a CMASIC that can be put on a board, can soldered on a board. But all of these dongles have the same functionality. So we have several form factors, but one technology. And how does that technology really work? So as you know, we are working since 30 years in the software protection and licensing sector. And that's exactly what we use for storing the private keys and the certificates. So we have such, we use our proven technology that is used in several millions of dongles and CMAC licenses in the world to store that. And how does it work? So on the left side, you see such a license container. Since we are having a with CodeMeter a system for software protection and licensing, we call it license container. So a license entry is just a combination of a firm code that is assigned by WIBU-SYSTEMS and shows that you are the company who are allowed to use that firm code, and several product codes chosen by the ISV. So for example, on the right side, you see that license container. That's a dongle with the firm code 60010. And you can assign product codes normally to functions of your application. So maybe if I want to allow my customer to use the basic application of a basic function of the application so that he can start the application, he needs the 201,000 product code. So a license entry 60010, 201,000 leads to the fact that he can start the application. If you add another license entry, 201,001, then the customer is able to use an additional functionality of your software. Of course, he has to pay for it as well. And same story with the product code 201,002. So that's another functionality. But we are talking about storing keys, cryptographic keys and certificates. How does it work? So each of these product codes has so-called product item options. And these product item options that we see here on the next slide are mainly focused on licensing models. So you see an expiration time so that a license expires after a certain period of time. Or you have a unit counter so that you can create a pay-per-use license model, or you have different product codes that reflects a feature-on-demand model, as I have showed it the slide before. So everything is focused on the licenses, but on the right side you see two product item options that are perfect for storing keys and certificates. So the protected data or extended protected data are used to store the certificates. So this is just a little bit space memory that can be used for certificates in that smart card chip, the SLE97, which is a protected area that can only be used by you, by nobody else. So it's not possible to copy such a dongle. It's not possible just to read out the values. And there is another product item option, that's the secret data on the bottom of the page. So this is the perfect store for private keys, because you can initially transfer a private key to that memory, and you can later on only use it. Nobody can read it out. It's just a write once memory. And so we have the perfect structure with our license models for storing the keys and the certificates. So at the end, you have the following structure. You have a firm code that is assigned to your company. You have different product codes that you assign. And each product code is able to carry the secret data, protected data, so that you can store the keys and the certificates in such a product code. So not only one, you can even have a lot of them. Theoretically, you have 4 billion product codes available. Of course, there are only a few of them can be used on a dongle. 200, 300 of them make sense. So you have not only the storage for one key or certificate, you can have more of them on one of such dongles. And now let's see how we can store that.
Yeah, as Stefan already told you, you can store one key and one certificate per product code with the CodeMeter Certificate Vault. And you already mentioned the certificates are stored in the extended protected data view, which can be read public without any protection, but that's okay because it only contains public information. And the key is stored in the secret data, which, as Stefan just said, cannot be read out, cannot be copied, and so there's no possibility to extract key. Yeah, the updating or the importing of keys and certificates in the CmDongles is possible via the common process from WIBU for updating CmDongles. That's on the one side, the online process with the CodeMeter license central. On the other side, we have the WIBU context files and update files, which can be used to transfer keys and certificates offline into the CmDongle. Yeah, the CodeMeter Certificate Vault supports standard interfaces to manage keys, to manage certificates, and to use them. So it supports the PKCS 11 standard, which is a standard interface to store, use, keys and certificates in a hardware token, so like a smart card or a CmDongle. And we also have support for the Microsoft key storage provider, which has the same functionality as the PKCS 11 standard, but it's the Microsoft way of doing it. And then we support the OpenSSL API. That is an open source implementation of cryptographic algorithms and protocols, which also can be used to with keys in the CmDongle to perform cryptographic operations or to secure TLS communications with keys in the CmDongle. And the main advantage here is that it's all standard interfaces which are already integrated in a lot of applications, and so there's no need to change these applications or to make some implementation which is needed to support the CodeMeter Certificate Vault. Out of the box, Certificate Vault works with such applications which are already using these APIs. So now we have some demos for you which will show how authentication can be done with certificates and the CodeMeter Certificate Vault. And then I will show you how to encrypt a file using the OpenSSL API and how to create a certificate with the OpenSSL API, each with a key stored in a CmDongle. So let us begin with the authentication example. So I have a web application which needs a certificate to connect to. So here we have the log of the web application. It's currently running, and now I will use the Firefox browser and try to connect to this web application under this address, and hopefully we cannot. We see nothing happen here. That's because of the browser not showing an error message, but oops, wrong window, sorry. It's the wrong window. Here, okay, we can see the error message here. Client didn't provide a certificate. Okay, we have no certificate sent to the web application. So, okay, let's fix that. Now we will use the CodeMeter Certificate Vault PKCS 11 implementation to connect with a certificate with this web application. So you can see here in the CodeMeter Control Centrum, I have connected one CmDongle with the serial number, which I want to use now to connect to this web application. Therefore, let's take another tab. We go to the settings in the Firefox browser under privacy and security. Right at the bottom, we can see here view certificates and security devices. Let us first check the certificates that there is nothing in. Yeah, you can see we have no certificate which we could use for authentication. So let's go to the security devices. We have here some software implementation of security devices which are standard built in by the Firefox, but we can here load and add our certificate vault. So let's name it. And now we select the PKCS 11 implementation of the same third vault, which I have right here. Just a library you can link and load. So, okay. So the browser got in the background. Okay. So here we have it, and we see there's a new device listed here, the same third vault as I named it, and it has one device connected to it. As I showed you before in the control center, there's the dongle. So we have some status information. I'm not logged in, short description, the manufacturer, WIBU-SYSTEMS, some information about the version, the serial number. Okay, so good. And then let us check the certificates. Okay, now I have to log in first. Yeah, you need a password to access the key on the CmDongle. Type it in and okay. And now hopefully, yes, we see here the certificate which is stored on the CmDongle. Let's try to connect to the web application again. Okay, it's loading. Okay, now we have a pop-up here. It shows a certificate. If we want to use it to authenticate to this web application, so we have here the information again, who issued the certificate, serial number, valid time, key usage, all the stuff we discussed before. And if I say, okay, I want to use this certificate, then we can connect. We have authenticated with the certificate to the web app. Okay. And here another point I can show you. Here we have the dongle, so that's the web application which lists all licenses in our dongles. And here we have the structure Stefan explained before. We have the firm codes and the product codes. And in this product code, firm code 10 and product code 100, there's the certificate in the key stored. Here are the product item options, as discussed before, the extended protected data. And you see here in plain the certificate. So it's compromised, but you can read it. If you can read binary or hex. Yeah, and here you see the secret data BIOS where the key is stored, and yes, we cannot see the content. So good. Our next demo, let me close this, now is how to use the CodeMeter Certificate Vault with OpenSSL to encrypt a file. Therefore, I will use the OpenSSL command line tool, which offers an interface to all these APIs from OpenSSL. Okay, I start the application, and now I have to tell OpenSSL that it should use the CodeMeter Certificate Vault implementation and algorithms, not the software implementation from OpenSSL itself. Therefore, I have the command engine and the path to my certificate vault engine. So engine, it's called the library, which is used to replace the software implementation of OpenSSL with a hardware token implementation. So this is the path to my engine and some parameters to check if the engine is okay and what does they support. If I hit enter, okay, we see some description of the engine and a name of the engine. Engine is important, and that it's successfully loaded. Now we can use the engine to encrypt a file, for example. Therefore, I need another command, decrypt, if I find it. Yeah, here we have it. Okay, I prepared a file here, my secret text, just a sentence in it, which we want to encrypt now. Therefore, we use the pkutil command from the OpenSSL. Let me step here. And you see the second parameter, or first parameter, is engine and the name of the engine, CmDongles. This is the engine we want to use. And we tell OpenSSL that the key will be loaded from the engine here, key from engine. And now we have to specify which key we want to use on the engine. And therefore, we set the serial number of the CmDongle, where the key is stored in, and the product code, 100. So maybe you remember I showed you here, we are in product code 100. Okay, let's minimize that. Okay, and yeah, we want to do an encryption. Encryption here. And the input comes from the secret text file I just showed you, and the output goes to secret text encrypted, which will be created by OpenSSL. And at the end, we have an option for the mode of SR, how we want to use it. Not interesting now. Okay, so engine set, engine used, no errors here. If we check the directory R, we have a new file here called secret text encrypted. If you open it, oh, looks like garbage. Yeah, hopefully not. That we will check. So we want to check that all was fine. So we should decrypt again and have the text back we put in. So let's take, it's the same command. We have again set the engine, set the key form, it's engine 2, loaded from the engine. It's the same key we want to use, but now we want to decrypt, not encrypt. Yeah, change the files. The input file is now the encrypted file, and we have a new file for the output and decrypted text file to see that it's the same as the import from the first command. If we hit enter, again, no errors, and we should have a third file here. Yes, decrypted, and there's my sentence. Text back. Okay, fine. The last thing I wanted to show is how to create a certificate with OpenSSL and the certificate vault. Therefore, we have another command here, which is request new. So I want to have a new certificate, X509 certificate. Again, I wanted to use the engine, and the key form is again engine, because I will load the key from the engine again to sign the certificate. The key is as before, from the serial number and the product code. Now I can specify the format of the certificate, and it's the DER format, standard format for certificates, and I will name it democert.crt. Okay, now it will ask us for some information about who I am and what should I put in the certificate. So here we are in Germany, we are in Baden-Württemberg, and in Karlsruhe. Company is WIBU, again WIBU. And now I put a name here for a certificate, which will be used and displayed everywhere. So call it democert. And I can put an email address here. Yeah, everything we have seen before. Okay, fine. And now we should have a certificate here. Yes, right. Yeah. Okay, that's now in German because I don't show it you. Yeah, that's the representation of a certificate in Windows, and everything worked fine. Okay, so good with the demo so far. Let's go back if I find the right 9, 5. Oh, no. Which one? Good one. Okay, so I'm done with the demos. I have showed or demonstrated how to use the CodeMeter Certificate Vault to implement authentication with certificates, and how to perform cryptographic operations and create a certificate with a key stored in the CmDongle. Now, one point is left open, and that was the simplification of PKI processes with the CodeMeter Certificate Vault and the license center. This will be explained in this figure. So as you remember, we had the problem of authenticity checking to check whether a person or entity is allowed to request a certificate. That can be solved with the CodeMeter license handler, and that's the first step here. We have an authorized user or an admin who can register dongle IDs in the CodeMeter license handler, yeah? And these IDs will then be allowed to request certificates. Yeah? We have 3 machines here at the bottom, machine A, B, and C. We see a X here for machine B because the dongle ID of machine B is not configured in the license handle, yeah, to request a certificate. So, but machine A and B are, so they can send their dongle IDs together with a signing request, a certificate signing request we had before, to the CodeMeter Certificate Vault extension. The extension will check the IDs, the CmDongle IDs in the CodeMeter license handle, and if they are registered there, then CodeMeter Certificate Vault extension will relay the signing request to the connected certificate authority. Yeah? It's directly connected to the certificate vault extension via an interface which can be implemented, and the CR will create certificates and sign them and send them back to the CodeMeter Certificate Vault extension. The extension will then convert these certificates and keys to the well-known WIBU-SYSTEMS raw files, the update files, and these update files, which are encrypted to keep your keys and certificates safe, will be transmitted back to the machines, machine A and C in this case. And there you can apply these updates and have your keys enrolled securely into the CmDongles. And that's how you can simplify the enrollment process with the CodeMeter license handle and CodeMeter Certificate Vault.
Yeah, you mentioned the CodeMeter License Central. That is not a new product for WIBU-SYSTEMS. That's a standard one that we have developed years ago for our license management, and this is just an entitlement server that delivers licenses. And please remember, the certificates and the keys are parts of the licenses in the product item options that delivers these licenses to the end customer or the end device using a so-called ticket activation system for that. So you see the management system on the left side, that's the issuer of the certificates. You see a person or a device on the right side, that is the one who wants to get the keys and the certificate. And in the middle, the license central is located and cares about the management of that. So with a few steps, the license, so the keys and the certificate are transferred to the customer. So first of all, there is a request to the license central to create a so-called ticket and activation code that allows the device or the person to get access to the licenses with the keys and the certificates, and to activate them on the system or on the dongle. So a ticket is nothing else like a number digit variation. It's a password, if you want to name it like that. And with that password, the person is allowed to get the keys and the certificates. The fingerprint of the dongle is used so that it is clear that it is just a certificate, especially for that serial number of that dongle. That was what Philip mentioned before in that slide before. And with the ticket, you are allowed to use that, or allowed to get that certificates and keys. And in the fifth step, there is the rollout of the keys and the certificates to your dongle. So that is the technology that we use for a long time to deliver licenses in a secure and efficient way. And now we reuse that mechanism together with the CodeMeter Certificate Vault to issue, to enroll certificates and keys. So that's the system behind the scene, and let's have a summary look to the certificate vault. So it supports standard interfaces, PKCS 11, the Microsoft KSP, and OpenSSL. There is the import via WIBU-SYSTEMS, that is the update file that we use in the offline case. We have the use of certificates read-only. We support the RSA with 1K or 2K bit length keys. And it's designed for our CodeMeter runtime, which is the system that works for desktop PCs running on Windows, Linux, Macintosh, but also on embedded systems, because we are working with our technology also on industrial devices that are, of course, also controlled by software. And the CodeMeter Embedded API and library takes care about devices with low performance, with low memory, so that the technology also can be used on these embedded devices. And of course, the recommendation is to have a CmDongle, because hardware-based security is in the moment the best one you can get. So it makes sense to use that in this case. So that was that is the last slide of our webinar. So let's have a closer look to the questions that come up in the chat. There's one question that is directly related to that slide here. That's fine. So the question is it necessary to use a CmDongle? From a technical side, no. As you see on that slide, there are CmAct licenses, which represents plain software activations without any hardware, but it works in the same way like such a dongle. So it's more or less a kind of a virtual dongle, but as I mentioned before, the best way, the most secure way is to store the certificates and dongles in the smart card chip of the dongle. But from a technical side, it's possible to use CmAct license without hardware as well. And of course, CM Cloud is also coming up with our product line in CodeMeter. So both of these additional CM containers are supported sooner or later. In the moment, the CmDongle is the one who is the first choice. Then we have another question in the chat. So the question, that's something for you, Philip. Do we support the complete PKCS 11 standard or only parts of that?
At the moment, we just support a part of it, but the essential part. So we support everything you need to do authentication, to perform signing or encryption. All the needed crypto operations are supported with RSA 2K, as you just said. And the other APIs which are additional, and like storing new keys and new certificates in the dongle via PKCS 11, that will be added in one of the next versions.
Yes, and one last question. Don't worry, we will answer all the questions that come into the chat later on. But there's one interesting question that is related to the license central. So as Philip stated before, the creation of the keys and the management system has to be adapted to the license central that is shown here in that slide. So how do you perform that? So the License Central is not just an entitlement server tool. It also offers web service interfaces to create, for example, the licenses and to add the keys and the certificates to the product item option. So it's possible to have a back office system that creates licenses, licenses with certificates and keys, so you can remote control the License Central and adapt it and integrate that in an existing infrastructure in your company or in your processes. So that's all for today. I want to thank you very much for your time you spent with us. I want to say goodbye, stay healthy, and I hope you will join one of our webinars after the summer break. So thank you very much again, and bye-bye.
Thank you. Bye.